Hello, everyone, and welcome to this session of Multiple Universes. I'm James Barbieri, Associate Program Director at the Power Center, and I'll be your host. So any problems, technical or not, just feel free to just drop me a message in the chat. Before I begin, I'd just like to very briefly go through a couple of Zoom rules for this session. First of all, if you could please keep your microphone turned off during presentation and Q&A, just to ensure good quality audio. But at the same time, we encourage you all to turn on your camera. During Q&A and discussion, if you want to ask a question or make a contribution, you can use the raise your hand function or physically raise your hand or write your question in the chat for me to read out. And finally, this session is recorded for archival purposes and for you all. I know this week we were a bit delayed with giving you the recordings, but with this week we'll be back on giving you the recordings about 2 or 3 days after the session. Okay, now we can begin. Today we have the honor of introducing Ruth Kastner. Ruth received her MSc in physics and PhD in history and philosophy of science at the University of Maryland. She has since taught and researched foundations of physics, particularly focusing on the interpretations of quantum theory. She is author of several books and has presented throughout the world on the interpretational challenges of quantum theory. Today, Ruth will be talking about discovering multiple possibilities in quantum theory. And with that, I'll pass it over to you, Ruth. Welcome.
Thank you, James, and thank you to the organizers for inviting me, and thank you all for sharing this time with me. Let's see, I'm going to go ahead and do share screen here and get to my PowerPoint. Can everyone see that initial slide? Okay. So in keeping with the theme of this session, of this set of workshops, I titled this "Discovering Multiple Possibilities in Quantum Theory," and I mean to sort of just summarize the basic idea that I'm going to discuss with some different ramifications of this. What I've arrived at in my study of quantum theory is the idea that if we want to be realist about it, in other words, if we want to take the theory as really telling us something about reality, really referring to something real in the world, as opposed to just, kind of a recipe for predicting and classifying experiences and so on. If on the other hand, we want to be realist about it, which means thinking that it is describing something, then it turns out that I think the only coherent way of understanding what it's describing is that it's describing a level of reality that is a form of possibility. So not just any possibility, but a specific kind of particularly quantifiable, potent possibilities that we can have some empirical access to, in the sense that they lead to predictable kinds of phenomena, but yet they have this quality that we'll talk about in a moment, that makes them very different from the usual kinds of things in the world that we're used to thinking of. So with that sort of broad introduction, I'm going to go ahead and, oh, now why is this not? Okay, there we go. Okay, so starting out with just kind of recalling some of David Bohm's motivations, since he was a realist about quantum theory. We're going to talk a little bit about some of his motivations and desires for understanding quantum theory. So he was not satisfied with the Bohrian instrumentalism, which, instrumentalism means just treating a theory as kind of a recipe for predicting phenomena rather than taking it as describing something in the world. So he dissented from that Copenhagen kind of view, and he was seeking a realist explanation for the efficacy of quantum theory. So this 1952 hidden variables theory that he came up with, that back when I first began studying quantum theory, I was an advocate of this this hidden variables theory. So I saw in it the idea that there should be something underlying what we see, that there's somehow something more going on than what's evident at the usual classical level. And that's what I liked about it. I then later moved away to a different approach, which I'll be talking about today. But the basic significance of Bohm's work remains, and he discussed the idea of the implicate order versus the explicate order, and this is going to recur in a new guise. I'm going to try to make the case that we still have that insight by Bohm, excuse me. They're just different by one last letter there in their name. So this insight of Bohm's, that we have a kind of an implicate order versus an explicate order, is very much still in play, I think. And I was just reading some of the conversations on the sutra board, and I was struck by Basil Hiley's comments about Bohm, that he thought it should be called quantum non-mechanics. Indeed, this is really important, and I think we'll see more of what I mean by that as we go on. Okay, let me find my little arrow here. So first, we're just going to briefly review some of the perplexities of quantum theory. Before I go further, I should just mention I've planned roughly an hour, perhaps a bit more than an hour of slides. Then we'll take a short break, and then I'll be happy to chat with you. We can questions, comments, concerns, whatever you would like to discuss that comes to mind after the presentation. So that's sort of the structure. Okay, so the perplexities of quantum theory. Well, we have the famous measurement problem, which is illustrated in the form of the Schrodinger's cat scenario, where the usual form of quantum theory seems to land you in a situation where you have macroscopic objects seemingly in superpositions, but we never see those. And so this has spawned all kinds of puzzles, like Wigner's friend, that even heighten this problem, so that basically the challenge is, where does the quantum level end, and where does our sort of classical macroscopic world of experience begin, and what is it that bridges that gap? So it's a very famous gap that I will argue cannot be bridged in the usual formulation of quantum theory. So then we have uncertainty, the Heisenberg uncertainty principle, which is the observation that quantum systems, in a sense, are not, in terms of the usual kinds of position versus momentum. If Heisenberg showed in a very quantitative way that if you know where a quantum system is, then its momentum, its motion, its state of motion is maximally uncertain. And on the other hand, if you do have precise information about its state of motion, then there's absolutely no information about where it is, and it's maximally non-localized. So this kind of behavior is very counterintuitive, because in our ordinary world of experience, we see, we're pretty sure we're seeing things. I've got my little teacup here that I see that it's not moving at all, and I see where it is. So clearly there's something very strange about these quantum objects that, once again, doesn't seem to be the case for our ordinary experience. Then there is entanglement and non-locality. And this is a feature in which if you have two or more quantum systems that have a particular kind of relationship that we call entanglement, that in a sense, whatever happens to one of them seems to instantaneously affect its partner, and they could be sent out in opposite directions, so that when you do your measurements, the measurements are happening at different ends of a galaxy, or even two different galaxies, and somehow what one person measures in one galaxy instantly has to dictate to the other, its partner particle in the other galaxy, many hundreds of light years away, thousands of light years away, what its state is going to be, and what its probabilities are for various measurements. So there's this seemingly faster than light communication that goes on. So these are the puzzles that we're faced with. And standard interpretations try to deal with these puzzles, but I'm going to argue that they don't do very well. So just quickly going through some of these, complementarity, it can be, the term epistemic means it describing states of knowledge. So it can be useful in the sense of saying, well, if I know, something about a particle-like behavior, then I will know that I cannot know about its state of motion, which is described by wave-like behavior. And it kind of tells you, well, what can you expect to know at any one time? But it doesn't, and it doesn't really, the problem with complementarity is it doesn't help you deal with this issue of what is the transition from the micro to the macro level. So it just doesn't really solve those kinds of problems. It cannot help you with the measurement problem, for example. And let's see. Okay. People are often invoking mind or consciousness to try to collapse the wave function, or to get kind of this idea that, well, if I look at the box that the cat is in, then that means I've collapsed it, and so on. But that doesn't really help, because you have to define, well, what does it take to collapse this wave function? What is required? What counts as an external conscious observer? And the Wigner's friend scenario is a way of heightening that problem and saying, well, there's no principled way to say that at some point this magical collapse happens. So that just doesn't really solve this issue of measurement either. And then, of course, we have instrumentalism, which is a prohibition against interpreting the quantum formalism as referring to something real. So it's basically anti-realist. And often the motivation for this view was that it was assumed that to be realist about quantum theory means you're kind of being cheap about it, and you're saying, well, I'm going to throw something into the theory that isn't really there, like some form of hidden variables, that it's going to give me a classical determinacy. And people kind of felt that this was a cheap way of getting classicality. And the term anschaulich means picturable. So we certainly can't get anything, if we're not going to add anything to the formalism, we're not going to get picturable classical kinds of concepts to help us understand what is behind quantum theory. But that doesn't mean that we can't be realist about it. So so the people who were being anti-realist really kind of assumed that realism means classical realism, and it doesn't. So that's what I'm going to elaborate in what follows. So then we have appeals to quantum information, where there's no real clear definition of what do we mean by quantum information. There's quantum Darwinism that appeals to decoherence in the standard account that has unitary means basically deterministic evolution. And this doesn't really work because I've argued that it doesn't really work because you have to kind of smuggle in classical assumptions at the very outset to get the kinds of classical phenomena out of it that you need to reconcile the quantum and the classical or macroscopic domains. So the basic point here is that all of these approaches that I feel are not successful are actualist, meaning that they assume that everything in the world has a certain kind of ontological status that I'm going to call actual. It means that it's, in a sense, determinate, fixed, classical, mechanistic kinds of facts. So when people are kind of considering and promoting these views, they assume that reality has to be composed of these actuals, these kinds of static facts. And what I'm going to argue is that no, we need to have a broader understanding of what reality, what it means to say that something is real, that real need not mean actual in this sense. So I'm going to elaborate on that. So before getting into these more ontological issues, I'm just going to let you know that one of the things that you need to get past these puzzles and to get at least an account of measurement and so on is a transactional kind of understanding of the quantum formalism. And this is based on a different theory of the way fields behave. And this theory it was originally arrived at by Wheeler and Feynman, although there were some people working before they really formalized it. Tetrode, I think Sackler and Tetrode and others. So there are some unsung heroes behind this direct action theory. But just a quick introduction of that idea, that it takes not just an emitter, but also an absorber to have an active role in what happens in terms of conveying energy. So just a brief introduction to that, and we'll get back to that in more detail later. But the basic idea under this under this theory is that the basic field propagation is time symmetric. So that means that it behaves in a way that is counterintuitive from our ordinary kind of experience, that it, in a sense, acts in both temporal directions. And this is what's called the direct action. This is what is referred to by the notion of direct action, because it's non-local, which is another reason that it's very counterintuitive. And so if you have here two electrons, we know that electrons repel each other. And according to the direct action theory, this repulsion, this force that repels these particles, mutually repels them, is conveyed by a kind of a photon that's really only virtual. It doesn't convey real energy. It has a kind of a direct connection between the two charges, but there's no energy conveyed. So it's a subtle notion that this is force only. And this is, again, unitary, meaning that it satisfies the usual deterministic kinds of evolutions in quantum theory. So this is what I identify as the quantum level of possibility. And we termed this in a paper I wrote with Stu Kaufman and Michael Epperson. We termed this, kind of, if you want to think of it as a kind of a substance, res potentia, because it's a new kind of metaphysical category. So that the idea is that these kinds of interactions are taking place at the level of possibility. So this is not actuality. This is not space-time actuality. It's actually a pre-spatiotemporal domain of possibility. And now, on the other hand, when you do have energy being transferred in the transactional picture, there's a different kind of process, and it actually elevates the fields, which I'll go into in a little more detail, to a kind of a non-unitary status. And at the non-relativistic level, this has been referred to as absorber response, although it's really more mutual. It's really an interaction between the emitter, in this case. This double line here is representing an electron that's bound to an atom, and this is another electron passing by. And here is a radiative process that is non-unitary, meaning that something above and beyond this usual force interaction is occurring. And we're getting real energy, and that real energy, it looks like a double line in the transactional picture, which we'll get to in a little bit more detail later. So this is actually a different kind of process. It involves a real photon as opposed to a virtual photon, and it is non-unitary. And this is where we can get measurement. Okay, so there's an actual physical process there. So this is what quantitatively leads to, if you work out, the actual physics of it, it leads you to be squaring the field amplitudes, which gives you the quantum probability law called the Bohm rule. And this is where you get your classical space-time level of actuality, which we can call res extensa, and kind of identify that as pretty much similar to the Cartesian notion. So this is what really constitutes measurement. Okay, so to summarize, we have these two different kinds of processes in the transactional picture. We have a force-based unitary internal interaction at the level of possibility, which we can identify with Bohm's implicate order. And then on the other hand, we have another kind of interaction that conveys energy. It's energy-based, typo there, sorry, energy-based. It's non-unitary, and it becomes an external kind of process because it leads to observable phenomena. And that is identified with res extensa. And we can identify this as the explicate order. So basically what I'm offering you here is the idea that the transactional picture is really picking up on Bohm's insight here, that we have an internal kind of process and we have this external process that translates from the implicate quantum level to the explicate classical level. And that is really where we get measurement. So this latter process is the measurement transition that in the standard approach to quantum theory, there's no reason for it. It's just kind of, you say then a miracle occurs, because there's just no physics in the standard formulation of quantum theory that can get you that. But you do have it, you do get it in this transactional picture. Okay, so now I'm going to have a little perhaps digression here to kind of remind us what is the traditional Western metaphysical paradigm that I'm going to be criticizing. Okay, so we have, to a great extent, it's based on Cartesian dualism, this dualism of res extensa versus res cogitans, the sort of the physical, the material versus the mental, where there's no interaction between them. This is the famous mind-body problem. Or another variant of that is to have materialism, in which case we have it's assumed that only res extensa exists. So this is actually a very prominent ontological metaphysical commitment on the part of many physicists, many physical scientists. And that corresponds to what I'm calling actualism. So Cartesian dualism, just to kind of, look at it, is the idea that, well, we've got these things like apples that we can, interact with on a sensory level. And then on the other hand, we've got this ephemeral sort of abstract stuff that's mind. And, never the twain shall meet. Okay, so there's that. Then we have, for just materialism, it's denied that there's any sort of mental substance, and all we have is things, material things, materialism. Okay, so moving on now, this leads us to the idea that things or separate concrete objects are fundamental. So that's a picture, very common metaphysical commitment, that this is what the world is made of, just these things. Okay, a bunch of different things, and they interact with each other in a very local way, and so on. And that's what the world is made of. Okay, and then another aspect of it is to in terms of the Eastern concept of yin and yang, that it's not noticed in Western thought that we're all yang. Everything is all yang. There's no yin. And this idea that, just reviewing, which I'm sure most of you already know this, but yang is the initiating, creating, offering, emitting kind of dimension of action. Yin is the responding, destroying, accepting, absorbing dimension of action in the world, and that they're both really needed. Okay, so this is the big, I think the big affliction affecting quantum theory and Western science is this idea that this is all that's happening, and that you don't need to take into account yin at all and just kind of, ignore it. So this is kind of captured in the idea of the baseball, what I call the baseball picture of physical processes. Propagation is assumed to be unilateral. Now, in this case, there was a pitch. So pretend that he just hit the ball off a tee or something. Okay, so the baseball player is initiating the ball's trajectory, so that nothing happens unless a player hits the ball. Then everything happens. Nobody needs to catch the ball for it to complete its trajectory. I mean, that's kind of a silly thought, right? I mean, if I throw a ball out, that ball's going to, in macroscopic experience, nobody needs to catch it, right? And once I've thrown it out, it just goes on its merry way, and nothing else is needed. So this is the sort of everyday experience that is projected into the microscopic domain, and it's assumed that everything works that way. So this kind of leads us to the idea that one hand can clap. If you kind of think about it, if all you've got is yang, then you're asking yourself, what is the sound of one hand clapping? So I propose that this cone is actually what's describing the measurement problem of standard quantum theory, because it neglects yin. So I'll get back to that and elaborate a little bit further. But so just kind of summarizing, okay, so getting to another one, the idea of locality, that field propagation is a kind of a bucket brigade. So let's look at that. So, okay, so it's tacitly assumed that for anything, any sort of an influence to get from one object to another object, you must have this sort of a very local bucket brigade. And these are called, I'm calling these localized field operators. That's a reference to the idea that in standard quantum field theory, you have at every space-time point, it's assumed that there are space-time points, and at each point is associated operators, creation and destruction operators that must carefully convey as an independent mechanical system any influence that goes from, this is sort of playing the role of an emitter, and then something down here at the other end is playing the role of the absorber, and that you must have these guys, carrying localized buckets of the field very carefully in a very local way. So that's the bucket brigade classical picture of field propagation, even though this also applies to standard quantum field theory, because that idea of locality is built in because people want that. They want that locality. So I'm going to argue that, in fact, these are all conceptual limitations, and we need to break free of them in order to resolve the problems that we have in quantum theory, and also in making progress in this sort of wider realm of philosophical inquiry into the nature of reality. So let's see what's involved with that. Okay, so right off the bat, the transactional, I'm calling it interpretation because that's what it was originally called, but it's more than an interpretation. It really is a different formulation of quantum theory. And even though it is empirically equivalent, so anyone who wants to get into that later, we can chat about that. But the key aspect is that it includes yin. It's based on the yin element is included in the form of the absorber's crucial role. Okay, so it's developed, it's based on this different theory, the direct action theory, and it rejects all of these typical assumptions. It rejects the baseball picture of unilateral propagation. It rejects the idea that information must always be transmitted locally. And it rejects the idea that energy is always located at some space-time point, that either energy or force is always located in that way. This is the bucket brigade picture. Okay, so we need to reject that. I argue we need to reject that. Okay, so the direct action picture does include this yin aspect of response and acceptance in the active role of the absorber. And that is what allows it to remedy certain inadequacies in standard approaches to radiation, both classical and quantum. So again, the standard theory represents radiation as unilateral, but you can't really give away something without something receiving it, right? You can't sell your home without a buyer. Standard quantum. Is there somebody? Thought I heard somebody with a question. Just pausing for a moment.
It's okay. It was just somebody wasn't muted. Sorry.
Okay, no problem. All righty, thanks. Okay, so standard radiation theory that has this yang only character has to add this sort of ad hoc free field to account for the fact that an accelerating charge loses energy. So the direct action Wheeler-Feynman theory remedies this problem, but it was historically devalued and ignored because of its unconventional aspects. And it's actually not widely known that Wheeler returned to advocating it in 2003, but by then people had kind of, it had been stigmatized so much that it was really not seriously considered. So I'm going to briefly touch on some sociological and cultural aspects that I think may underlie the usual kind of rejection of these kinds of theories that involve taking absorption into account. And this is just the idea that in Western culture, ideas like creation, emission, initiation are seen and appreciated, but absorption, reception, responses, and that kind of mode are unseen and unappreciated. An example of this is that until very recently in reproductive biology, it was assumed that the egg was just kind of sitting there very passively, and that the sperm were unilaterally carrying out the functions of reproduction. And it was only very recently that it was discovered that, in fact, these are some electron microscope micrographs, so that the egg is actually undergoing enacting some important physiological and chemical processes. This is called a fertilization cone here in the egg that's enveloping a sperm, and it's also preventing the egg actually sends out chemical signals and sets up barriers to prevent any other sperm from entering. So in other words, the egg is doing something very crucial in its role as accepting and responding to this whole reproductive process, and it's kind of an equal player in the process, without which there would be no reproduction. And because of cultural biases, I think it was Emily Martin who wrote a kind of a groundbreaking article. She was an anthropologist who observed it through her research that these kinds of stories were being told about, the valiant sperm, overcoming all these obstacles to get to the lady in waiting, and she, it was romanticized tales, and she realized, oh, no one has actually looked at this. And when they did, then they realized that in fact the sperm were not all that great at swimming, and they needed to have these signals from the egg to avoid getting lost, and so on. So not to belabor that, but we have, the bottom line is that the Western culture is skewed in that way, and doesn't realize that it's skewed. So getting back to trying to kind of even the scales a little bit, and looking at the quantum version of the absorber theory, which is the transactional interpretation. And I've been doing some work on the original transactional picture and extending it into the relativistic domain. So let's see. So just kind of not going into any more details for now on that, but with yin back in the picture, we can clap, we can shake hands, and we can get measurement outcomes. So by taking this, the yin aspect into account in formulating quantum theory, we actually get an explanation for measurement, and a quantifiable explanation for measurement. For now, I think I'm going to see how I'm going to, how am I doing on time as far as, I don't have a clock in front of me. Let's see.
It's 35 past, so it's
okay, good. So thank
time.
you. All righty. We'll just quickly go through when we have more than one absorber. We have what we call an offer wave in the transactional picture, so that the emitter is contributing this state. Okay, we'll call it psi. But when you have different absorbers, this entire offer wave does not get transmitted to each absorber. In fact, each absorber receives a projection of it. So an absorber, depending on its physical state and so on, can only respond to a certain component of the original offer wave. So in this sense, it kind of divides into different components. And if we have absorbers A, B, and C, then each of them will see its own component, smaller component of that original offer wave. And then these absorbers respond. This is the contribution of the absorber. This is the yin element. This is a response that's missing in the standard formulation of quantum theory. These are called confirmation waves in the original parlance of the transactional interpretation. And so in quantitative terms, they are the adjoint or complex conjugate of the element or the component that they received. So what happens is when you have the, just going back, the interaction of these offers and these responses, you get a kind of a handshake, a metaphorical handshake. And each of these is represents a possible transfer of energy. to one of the absorbers. But since we have a single quantum in this case, they can't all receive this single quantum of energy. So, and this is again going back to the idea of quantized things, which is a feature of the quantum domain. Not in classical, in classical physics, we don't have this at all. And it's the quantized nature of energy transfer and other conserved quantities that makes this whole structure necessary, where you have to kind of have a collapse. You can't, this piece of energy cannot go to all the responding absorbers. So what you get is only one of them ends up receiving it. This is collapse. And what I've done here is I've just kind of shown that formally these interactions are described by what's called the outer product of the offer and the confirmation. So these quantities here, this is called a projection operator, and each of the projection operators, when you take the direct product of the response and the offer, you get this quantity here that is multiplied by the Bohm rule. So this is where the Bohm rule comes from in the transactional picture. It's actually a physical process. And when I say physical, I don't mean actual. Again, these are not classical phenomena. These are behind the scenes, sub-empirical interactions at the level of possibility. But they're very real. And they do give rise to these weighted projection operators that give you the Bohm rule as these coefficients. So again, each of these is what I call an incipient transaction. They can't all be actualized. So only one of them is actualized with the corresponding probability. And you can think of this as a kind of spontaneous symmetry breaking. So, but there is real collapse happening here. Now, for those of you who are familiar with von Neumann's formulation, he talked about the measurement transition as involving this, what's called a pure state, being transformed to what's called a mixed state. And he noticed that this is the way you represent it mathematically, but he could not give any physical reason for this transformation. It's non-unitary. And because he believed, like everyone else, that quantum theory is really only unitary, then he was kind of at a loss to explain what is it that leads to this transition. But in the transactional picture, you see that you simply do get this transition because there's a real non-unitary process in the physics that really happens. Okay, so now here I want to go back to one of Bohm's writings that he wrote as a contribution to the book by Hiley and Pete, the book entitled Hidden Variables and the Implicate Order. I'm sorry, Bohm's contribution was entitled Hidden Variables and the Implicate Order. And the book was a collection of writings in honor of David Bohm, Quantum Implications. So this was just a wonderful retrospective kind of commentary by Bohm on his thinking. And you can all read, but I'll just go ahead and read through it because it's such a wonderful observation. So Bohm says, I felt particularly dissatisfied with the self-contradictory attitude of accepting the independent existence of the cosmos while one was doing relativity, and at the same time denying it while one was doing quantum theory, even though both theories were regarded as fundamental. I did not see how an adequate way to deal with this could be developed on the basis of Bohr's point of view. So I began to ask myself whether another approach might be possible. In my first attempt, I considered a wave function representing an electron and supposed that this was scattered by an atom. The scattered wave will spread out more or less spherically. Nevertheless, a detector will detect a localized electron, while the extended spherical wave gives only the probability that it will be found in any such region. The idea then occurred to me that perhaps there is a second wave coming in towards the place where the electron is found, and that the mathematical calculus of quantum theory gives a statistical relationship between the outgoing and incoming waves. Well, here we go. This is really a transactional process in Bohm talking about this incoming wave, because that's really kind of the advanced propagation that we have in the transactional picture. So this is, I think he's describing his concept of the hollow movement. So it's, my observation is, wow, that really sounds a lot like the transactional picture. So we can, if any of you want to pick up on that, we can chat about that a little bit later. So returning to the idea of possibility, so this is a new metaphysical category that is not acknowledged in the traditional scientific paradigm. And I've explored this in connection with my relativistic development of TI. Now, I should just mention that the original developer of the transactional interpretation, John Kramer, does not agree with this. So he, he's working with the traditional scientific Western paradigm, and he has not been, kind of enthused about the idea of possibility. So this has been my development of RTI. Now, RTI is a formalism that can stand on its own regardless of your ontological commitment. So this is not obligatory, what I'm discussing here, but I do think this is the really only coherent and natural way to interpret the formalism. So I take it as referring to hidden aspects of reality, and returning to this idea of res potentia that we talked about earlier. So the domain of res potentia encompasses quantum systems and possibly mental entities. I'm going to touch on that a little bit later, where we get more speculative. It could be, we might want to think of quantum systems as some form of mental entity. I don't know, but that's an intriguing thought. Now, on the other hand, res extensa, I take as being the set of actualized events, results of measurements, and of course, these are well defined in RTI. RTI explains why you don't have cats in superpositions and so on. So you don't get the measurement problem in RTI because you have measurement transitions occurring at a very basic level before things can get to the point where you could ever observe a macroscopic superposition. Okay, so in my interpretation or my development of the transactional picture, it rejects this bucket brigade idea. It also rejects the idea that everything real occurs in a space-time container, which is the standard presumption among most physicists, and they don't realize, that this is an optional metaphysical assumption. They just take it as, well, any right-thinking person thinks that we all live in a space-time container, and that's reality is a space-time container with stuff in it. Okay, so I think that's wrong. I think that's something that we need to jettison, and to entertain the idea that quantum possibilities are not space-time entities. So the other wonderful observation that Basil pointed to in his comment, Professor Hiley, I should say, was that Bohm regarded the quantum level as organic. And I gave another talk recently that dealt more with specifics of identity in the quantum level, and I argued that quantum objects have a form of identity, but it's very different from the classical notion of identity in that it's organic and fluid. And these kinds of blended trees really represent the idea, that we have some saplings that grew up that began as so-called separate entities, but these were actually cultivated, these first two, but they were kind of guided to know about one another, and then they merged to form a single tree because they have the same, what I call quantum hexaity, which is just a fancy Latin term for being thus, but it's a quantum form of being thus, that this element of the tree, whatever kind of tree that is, those of you who are tree experts can tell me, and this element of the tree became the same tree because they did not recognize one another as other. They said, oh yeah, this is the same thing. We're all the same entity, and they merged. And similarly, this is very much quantum behavior, where you have, okay, maybe I've got two to what I call particles in an entangled state. Now I'm going to send one off to one area of the galaxy and send the other one off. Oh, now somehow I'm going to reunite them, and they don't recognize one another as other until, you know, they undergo certain interactions that may separate them at some superficial level, but fundamentally they are the same thing. And here's just another case of these same kinds of tree that started out as separate and said, hey, we're all the same tree, and they merged and they separate again. But they're never really separate. It's an organic kind of growth, an organic kind of process. So looking at these different substances or modes of reality again, the res extensa form is classical, particle-like, has this mechanical kind of quality, has local behavior, apparently determinate properties, which I will elaborate on a little bit later, obeys Boolean logic and classical probabilities, seems to have a factual framework, that's sort of the framework of things, and corresponds to a kind of a space-time domain. On the other hand, the res potential level, quantum, wave-like, organic, has non-local correlations, indeterminate properties, obeys the uncertainty principle, obeys a non-Boolean logic. This doesn't obey the law of excluded middle. It's not that you're either this or you're not. Well, no, you know, there's a fuzzy logic there. You can't apply classical probabilities to it. And it has a more of a becoming framework, that the term in statu nascendi is in a state of becoming, or in a state of being, of becoming something. And it's pre-spatiotemporal. So these are the contrasts between these two kinds of modes of existence. And another way of looking at it is to note that the classical level of res extensa is really just the tip of the iceberg, and that in fact there's a lot more going on beneath the surface. That this submerged portion of the iceberg is much larger, and in fact, in terms of quantum theory, it's just hugely larger than this tip, the domain of res potentia. So that the space-time theater is actually emergent from this sub-empirical level. Okay, so what I claim is that quantum theory is really trying to tell us that reality is bigger than we thought. So another way of kind of elaborating this is to think of the classical level as kind of the Kantian phenomenal level, the res extensa. We have the explicit third-party corroboratable events or facts, the actualities. We think of it as existing in space-time. It's empirically accessible, manifest and concrete. And then on the other hand, we can identify the quantum level with the level of Kantian noumena, or as he thought of it, things in themselves. So these are sort of the nature of things at a fundamental level, apart from being observed by anything or anyone, that they are res potentia, they have implicit tendencies, they're possibilities. Again, this is the implicate order in Bohmian terms. This is the explicate order. I argue that these comprise a substratum for space-time, but they do not themselves exist in space-time. They're empirically inaccessible, unmanifest, and seemingly abstract. Now, another kind of nice way to picture this idea of what I'm getting into now is the idea that the classical external explicate order emerges from the quantum internal implicate order realm, in a way that's kind of analogous to geode formation. So if you think of a geode, it starts out as kind of just a hollow cavity in some cooled lava, and then you have mineral-laden water that you can think of as raw possibilities that flow around these areas and gradually kind of seep in and crystallize out. So the crystals I think of as analogous to the actualized events, the measurement results, if you will. And so this kind of transactional process that crystallizes the fluid raw materials, the mineral-laden water, into these very specific actualized events. So in this picture, we don't need to invoke an external observer. We have a very specific process that, that discussed earlier, that is quantifiable, that leads to these actualized external explicate kinds of events. Now we can think of this as, we do have collapse, and we do have the idea of many possible outcomes reducing to only one. And so we can think of this as kind of perhaps at the level of nature, having to kind of make some sort of decision, if you will. If you don't want to think of spontaneous symmetry breaking, and if you want to think, well, there's some kind of impetus for one of these outcomes to be actualized. This is an interesting concept that Haag, a famous physicist who did some really important work in quantum field theory, he also referred to this idea of decisions in nature comprising the transition of possibilities to fact. So I think this is very much what we're looking at here, where we have at a fundamental level, the transformation of possibilities into fact always involves a kind of a many to one transition. So we're having that elevation of one of the possibilities to an actuality. So there's kind of a decision point there. Now, I think I'm going to just kind of go over this a little. I've passed through this more detailed explanation of the idea of a space-time interval emerging every time you have an actualized transaction. So I'm going to just, for an interest of time, we can maybe come back to this if people have questions about it. But this is a little bit more detail on how the many to one interaction occurs. And what we get is a new space-time interval that is actually established by having a real photon end up going from the emitter to the absorber in a forward direction. So this ends up establishing a fact and a real transfer of energy that I argue really constitutes a new space-time interval. So it's a new chain, or a link in the chain of space-time events. So you can think of this as a kind of a weaving of the space-time fabric from quantum threads, if you will. So you can think of the raw material as the thread. These are possibilities. And we can think of the present as being symbolized by the stitch that's currently being knitted. And it's always local. There's no meaning to say, to saying it's now everywhere. You can't do that. It just doesn't, it's not relativistically sound, and there's really no meaning to it. So the notion of now is always a local event that's defined with respect to a particular quantum system, if you will. So what we think of as the future is really those ontological possibilities. This is the yarn that you're going to use. Now, at any time I'm knitting this scarf, I could decide to change the yarn, different color yarn. I could decide to change what pattern I'm using. I could make a whole different garment. I can do anything I want, right? So if you think of this as the extruded content is space-time, okay, the past, this is my scarf falling away. The future does not exist except as the quantum possibilities. So there are the usual, we'll get to that in a minute, the usual way of thinking about space and time is that the future is a bunch of events. Okay, so this picture challenges that. So what we see is like the idea that an emission event is always going to be actualized in the past relative to a receiving absorber, because this knitting process is analogous to the transactional process. And whenever I complete a stitch, well, the result of that stitch is on my needle, sort of in my now, but the previous stitch, you can think of as the emitter, is in the past. So it's falling away from me in this sort of actualized set of events that is the past. A little digression here, and we talked about the classical level being apparently determinate properties. Well, when we have something like a bubble chamber picture, this is a classic picture that people have in these bubble chambers where they are having charged particles enter and and interact with the gas molecules and so on. And they give rise to these continuous classical looking paths. And it seems as though the particle's position and momentum are well defined on the path. But actually what we have here at a fundamental level is that the path is a series of actualizations brought about by these transactions. So it gives the illusion of a persistent space-time object, although that's not really the underlying ontology. What we have are phenomena that end up being the results of transactions. And at each point, there's a highly probable transaction that's going to rule out that some crazy thing that's jumping all around. But because of the physics of it, you're getting this apparently classical determinant path, but we're actually having the indeterminate possibilities leading to that phenomenon. So getting back to the idea of, well, what is the future? What is space-time? It's generally kind of assumed, this picture is the usual assumption, so that maybe, maybe I'm now, and there are a bunch of space-time events in my future, and there are a bunch of space-time events in my past. And it's kind of assumed that we face the future. This is kind of an implicit Western metaphysical thought. But actually, in the picture I'm proposing here, the future is not a set of events. The future is just, the term future, I like to kind of recall Eckhart Tolle. I don't know if any of you out there have listened to Eckhart Tolle's talks, and he very much espouses this same view, that he calls it the so-called future, because all that really exists in a sense is now, in terms of, I don't want to get off on that, but at a fundamental level, all we ever really experience is now. Now we can infer that actualized events are perhaps falling away from us, but we have no way of inferring that there are events in the future. And in fact, if this view is correct, if we are actualizing quantum possibilities that are giving rise to events, then really we are creating or are participating in the creation of these new space-time events. And interestingly, there's a group of indigenous people called the Aymara who live in the Andean region of South America, whose whole, even their language, reflects the idea that what you are facing is the past. So their language, when they have, they don't really have a future tense. They have, when they want to talk about what might happen, they refer to it as behind them, which is really interesting, and diametrically kind of opposes our way of thinking that we're facing the future. But in this picture, if you think of yourself as the scarf knitter, you're knitting the scarf of the past events that are going to fall away from you. That's what you're facing, because you see your past events, and as you look around you, what you're seeing are past events. You're not seeing the future. So in a real way, we are facing the past. We are not facing the future. So kind of something interesting to think about. And also analogously to the idea of a snake shedding its skin. So the living snake is contained in the now, and the shed skin represents the past events. So whatever, whatever is happening is kind of falling away from you, and you never go anywhere. You're always in the now. And that's the same picture that is implied by this transactional approach, where we are living in quantum possibilities, and the actualizations that are occurring are kind of like the snake shedding its skin. So those are kind of falling away from us. Those are actualized events, but in a sense, they're not really that important anymore. They're falling away from you, but at least you can quantify them and refer to them. So going back again to that idea that we're knitting this space-time fabric, but we shouldn't be kind of fooled into thinking that it's something that exists that we're moving through. There's no valid logical implication that future events exist. And in fact, we can solve a lot of problems if we let go of that idea, and that there are no actualized future events. Okay, so I'm going to check on my time here. I actually do have a clock.
It's 7 now. I'm not 7. Well, it's 7 here, but
Great.
the
Okay,
hour
so
has, yeah.
it's been about an hour. Okay. I think what I might do is, since it's been an hour, I have another section that goes a bit more into, it's a more speculative section. Is there a preference to have a break now, and then resume, or should I just go through this and then break? Does anyone have a preference?
I mean, if you're feeling, if you feel like you need a break, let's have a break. Otherwise, yeah, please continue, I would say.
Okay, well, I'm fine. I just didn't want to kind of go on too long without giving a chance for questions. But of course, if you feel free to write down any questions you might have, and we can revisit those. So so my next section here is a bit more speculative. I'm not a biologist. I am not a philosopher of mind. These I'm kind of venturing farther afield and take it in that spirit. I hope you'll just kind of, indulge me as I kind of go a bit speculative here and raise a few issues that I've thought about that I thought might be fun in this context to kind of explore. But keeping in mind that I don't claim any special expertise in these areas. Okay. So kind of thinking about, well, what, the mystery of life. I remember when I was about 8 years old reading a book. The title is escaping my, I forget what it was, but I was reading this very deep book. My parents were intellectuals about life, and they started talking about, well, where did life come from? Well, we had the planet Earth, and we had the Precambrian era, and all this goo, and like all of a sudden there were bacteria, and I'm like, whoa, wait a minute, something's going on here. What suddenly happened? And that's always been a mystery for me. What does life come from non-life? If so, how? Okay. But so I've always been fascinated by this idea of life. And so one aspect of life is that it's in this state of disequilibrium. This is kind of something that differentiates living systems from so-called dead or inanimate systems. Okay, so it's in this sort of state of disequilibrium. So if you toss a seed into the soil, immediately it starts to create non-equilibrium conditions around itself. I mean, I remember when I first got into herb gardening and I got parsley seeds. You toss the seed into some dirt, and it sprouted. You have to wait a long time for parsley, and it smelled like parsley. And I'm like, whoa! It just seems like a miracle. Okay, how did this little tiny thing start creating a smell? Very focused, entropy reducing processes. So it's kind of miraculous that living things make things happen. They initiate actions internally in order to consume what they need to grow, to evade threats, and procreate. The latter are functions. So this is the key idea. Life has functions. Death, equilibrium, nothing happens. You toss a pebble into the soil, nothing happens. There's no function. Okay, so apparently a pebble has no function that needs to be served on its behalf by doing anything. Okay, so this is kind of an observation you can make. But okay, so if we have a function, then it sort of implies the idea of a self. A self has to perform a function in order for itself to serve itself. A pebble apparently has no self. It doesn't need to do anything. Or I don't know, maybe itself is just happy, just lying there. Who knows? But anyway, the idea of a function can only be defined by relation to the self whose purpose is served by it. So Stu Kaufman makes this wonderful observation, and I have the references later if you want that. So what is this self, and why does the seed have it, but not apparently the pebble? I don't know, but we can make this contrast. Cells generate actions internally. The seed is generating actions internally. So now we have to have a little digression here. We're talking about choices and volition. Okay, human beings, we think that we have choices, but okay, now we have to refer briefly to the famous Libet experiments that people have taken as refuting volition or choice. No, they don't. Now, I don't want to get off to this into this right now, but that was actually, arguably a big misinterpretation that has been largely discredited. So I'm not going to spend a lot of time on that now. But basically, the message is, if you've been told by, Facebook and various magazines that the Libet experiment proved that you don't have free will, then don't buy it. Okay, and I can explain why you shouldn't buy it later. Okay. Anyway, so some neuroscientists have bought into that. The ones who haven't read their latest professional literature still buy into that. But they do agree, even among those who are up to date and know that the Libet experiments were not conclusive and have pretty much been refuted. It is true that the resting state of the brain has this ongoing level of noise. It's this non-equilibrium, critical or poised state that, again, Stu Kaufman has written about. So to initiate action requires a disturbance of this resting state, and the disturbance will generate a signal that results in the action. So the idea is again, life initiates action. Now, if you look at the neuroscientific literature, there's kind of a materialist assumption that underlies a lot of these writings, that takes it for granted that disturbances like this are all just responses to external stimuli, so that they model biological systems as effectively just kind of a very complex stack of dominoes. And so, then they get into this kind of conundrum where, well, again, if we're back to dominoes are not living systems. So once again, how are living systems really different? How can they be distinguished from kind of just a stack of dominoes or, puppets on a string? So I'm going to explore the idea, again, speculatively, that really what distinguishes a living system from, a set of dominoes is that it is really initiating actions internally without external stimuli. So it's not a stack of dominoes. So once again, if living systems can do this, then the ability to initiate action would be what distinguishes what we call living systems from non-living systems. So think about the brain. Okay, if the brain is just kind of a hunk of wetware, again, a material system, then again, it has to be considered as passive and only, again, kind of like a wet stack of dominoes, okay? So it can only act as commanded by some software or some programmer or user inputting commands. So once again, just a hunk of stuff, if it's considered to be just a material system, it cannot initiate any actions on its own. The brain cannot initiate any action. So if any action is to be initiated, who is this mysterious programmer or user? Either the brain can only be a passive material responder to external stimuli, or the brain has to be somehow internally generating actions. So basically, we have to kind of think about, we can't assume that a wetware brain as just a hunk of stuff can initiate any action. So is there a place for mind anywhere? Is there a place for volition to enter? And we can look at the quantum level for this. So the idea, the thing we can consider or speculate about or conjecture about is the idea that the wetware brain is just the tip of the iceberg in our earlier analogy, and that it's kind of some of the actualized crystals in the geode, but that there are other processes going on that give rise to those phenomena. But if all we can see is the tip of the iceberg, then the other processes are invisible to us. So if we consider the idea of mind as an element of the quantum level, an element of that level of res potentia, the process level, the implicate order level, that there's something going on at that level that could give rise to changes in brain states, to the relevant brain states of the disequilibrium condition, the ready state, if you will, and the changes through volitional action, even though there's no empirical access to those processes. So here's an analogy. If we think of, this is supposed to represent a tesseract, which is the four-dimensional analog of a square in 4 dimensions. So it's distorted down to kind of 2 dimensions in this picture. So there are some, all the angles are really supposed to be right angles. So you see, some distortion, but that's the way we represent a tesseract on a flat piece of paper, if you will. So if we think of our empirical space-time realm represented by this square, 3D, as embedded in a larger dimensional reality represented by the tesseract, we can think of our wetware brain as analogous to this square. Okay, that's the empirically accessible wetware brain that we can probe, but it's not the whole story. It's embedded in this larger dimensional realm. Now, if the elements of this larger realm are like the quantum entities that are underlying all of the phenomena, then they can and do interact with the manifest level. So suppose, okay, we just allow for that. Well, we cannot detect those processes. Those processes are sub-empirical. So could we speculate then, or conjecture that the origin of volition is beyond the empirical realm, analogously to this higher dimensional space? So again, in 3D, we're like people in Flatland, Edwin Abbott's story Flatland. We, like the Flatland people, we don't want to assume that, that the cube or the sphere coming in is lying to us when he says, oh, there's actually a third dimension out there. So we similarly have to be open-minded to the idea that there may be larger dimensional aspects to reality that really can interact with our tip of the iceberg 3D realm. So that's the suggestion. Okay, so suppose yourself, including your mind, and by that I mean both the pre-conscious aspects of your mind and the conscious aspects of your mind. Suppose you are the entire tesseract structure. So we can think of the mental aspects of yourself as everything beyond the central cube. That's your physical body, if you will. Okay. Topologically, everything is connected, even though the connections are not by way of the usual classical fields. They're by way of these quantum possibilities. So in this situation, the brain part of yourself might not be conscious enough to be able to signal to an experimenter, say, that you're aware of something, but other aspects of yourself in this larger dimensionality may be quite busy attending to other issues that cannot be represented at the 3D empirical level. In other words, behavior that an experimental would record as subject not conscious might actually mean subject's attention is elsewhere. So like someone in a coma, perhaps, or someone who's suffered brain injury would be called not conscious because they're not responding. But again, we don't know that. We don't know what they actually experience. And in fact, this is borne out by the experiences of Martin Pistorius, who was a victim of locked-in syndrome, and he recovered to the extent that he could write up his biography, his autobiography. And at times when people were assuming he was not conscious, he was quite conscious. So that's the tricky thing, is you cannot assume that by what you observe empirically that you know what's going on in the mind. So recalling Flatland, this is kind of analogous to our, think of us as a square in Flatland. That's analogous to our empirical realm. Think of the sphere coming and poking the square in his stomach. Well, the square is kind of freaking out because he's got these internal experiences. And certainly, if he would say, oh my God, something just poked me in the stomach from the inside, everyone in Flatland around him would think, well, you're crazy. But in fact, here I reference Martin Pistorius again. But in fact, at an empirical level, at the larger spatial level, a fellow sphere would say, oh no, it's empirically valid that you just poked that square in the stomach. So, it depends on your point of view what even counts as empirical, because the sphere and his fellow spheres, if they're floating out there, can corroborate empirically, yes, you are poking that square in his stomach. Whereas meanwhile, the other geometric shapes that are stuck in Flatland think the square is delusional, and that his experience is not corroborated empirically. So this is something to keep in mind, that a higher dimensional level, something might be perfectly empirical that could not be regarded as such at a lower dimensionality. So this just goes into a little bit more detail on, how we might get a mind-brain interaction such that you could have a quantum transition from some ready state. This is all happening outside the manifest empirical, laboratory, if you will. But something could go on at the quantum level, represented by the tesseract, that could trigger a change in the brain state. And if our mind is in here and our mind says, I'm going to choose a certain option, I'm going to affect a change in my brain such that I can volitionally act on my choice, then that would be an entirely internal initiation of this choice that would not be subject to, that would not be something that's just a passive response to external stimuli. So this is a way in which you could initiate choices at the level of your self, if you understand yourself as being, part of your mind, if you will, being perhaps an aspect of the quantum level. So it's an intriguing conjecture. We can think about that, and this kind of, it gives us an intriguing perspective on the idea of quantum measurement, that the idea of indeterminism at the quantum level need not be considered just randomness. In other words, the term random kind of implies just uncontrolled, but indeterminism simply means that at the level of the applicable physical theory, there's no mechanistic account for the transition from many possibilities to the occurrence of one. Well, what about volition? Okay, that's not random, but it's also not characterized by any mechanistic rule. So this provides a wonderful entry for volition into the transition from the quantum level to the actualized manifest level. And people have worried that this would violate the quantum probability law, but no, it doesn't have to do that. And I have an argument and a reference for why we don't have to violate the Bohm rule in order to have free will in this kind of form. Okay, so let's see. Just touching here on the connection that we can make with the work of Ian McGilchrist, who has talked a lot about the different lobes of the brain and how the left brain has this kind of mechanical character, the level of facts, that there are separate things, the gears represent the mechanistic kind of thinking, the classification, the explicate order, and that the right brain, in contrast, has this level of possibility, wholeness, non-locality, the implicate order. And this is beautifully described by Jill Bolte Taylor, the neuroscientist who underwent a stroke in which her left brain was basically taken offline. And she has written, very eloquently about her experience of this right brain reality, and how she, it took her many years to regain the access to her left brain and the full brain interaction, which I like to think of as kind of analogous to the transactional process. So if we have the left brain being the sort of the king of, or the supervisor of the space-time realm of actuals, clearly we need to interface with that to survive and so on. But that the right brain is very much in tune with the quantum substratum of possibles. And we need that too. And Ian McGilchrist, makes a very strong case that a lot of our dysfunction in the current world is the left brain dominance, and that we need to have the right brain much more involved and in much more balanced form of thinking. Well, this is kind of the classical, I don't mean classical, but the standard orthodox approach to quantum theory, I think, is similarly hobbled by left brain predominance. That it's assumed, as I recounted before, all these Western metaphysical precepts that we live in a space-time theater, and that everything is mechanistic, and that if you fail to give a mechanistic causal account for something, then you have to give up and throw up your hands and tell people not to talk about what's really might be happening, because what really might be happening is what's regarded as too crazy, is this kind of implicate order that is very much involved and yet kind of viewed as unscientific by people who think that science means only this. So the transactional process really connects, in a way, serves as kind of the corpus callosum, in that it links the transactional realm of the quantum substratum to, it expresses how, it shows how physically, when I say physically, I don't mean in materialist ontology. I simply mean that there's a theory that can tell you how you get from this realm to a more manifest level, in a way that is coherent and makes sense and explains how it happens, although it will refuse to give you a causal mechanistic account of how that happens. Okay, so let's see. So my conclusions here is that quantum theory is trying to tell us that reality is far larger than we thought, and that hidden quantum aspects of reality are ontologically real forms of possibility, res potentiae. The domain of res potentia is the quantum substratum. It's very real, that exists. And that all material systems actually exist in the quantum substratum. This is really interesting. It means that you and I are really in the quantum substratum. We are comprised of rest mass systems. We live in the quantum substratum. That's our home. We actually live, and the superficial level of our empirical experience is mediated by photons conveying space-time events. But that doesn't mean we live in space-time. That's simply kind of a theater of events that we are looking at. If you will, the space-time realm of events is our Plato's cave screen that we can look at. But we actually live in a far richer reality. Okay, so these systems undergo transactions which toss photons back and forth and thereby create these actualized events that are phenomena. That's all they are, phenomena. Okay, so yes, photons are real and they're real packets of energy and they do exist, but they comprise this space-time theater, if you will. So they're not the whole story. So the domain of these actualized events, is space-time. So in this way, we can identify space-time with Maya, with the Hindu concept of Maya. Now, it is not illusory as such, but it's only the superficial level of appearance. It's the tip of the iceberg or Plato's cave. Now that we can associate the left brain with the space-time level, and we can associate the right brain with the quantum substratum, and we can think of the corpus callosum as the transactional process that connects these two domains. So that's kind of, some of that is a little bit speculative, but these are ideas I've been entertaining. And again, want to credit David Bohm with important pioneering thought that really touches, I think, on some deep insights that need further exploration. I would try to make the case that the transactional picture may be a good way to further explore those insights of Bohm's. And I guess I'll conclude there and thank you again for the opportunity to present these ideas, and thank you for taking part. And I look forward to chatting with you a little bit after, I guess, we take a 5 or 10 minute break.
Yes. Well, first of all, thank you so much, Ruth, for that. That was a really incredible presentation, and I mean, my brain is still hurting from that last part. Maybe it's some quantum fluctuations happening in my quantum brain.
Ah, good. Okay.
But no, really fantastic. Thank you. Even your concrete examples really did help, definitely me, and I hope our audience understand these concepts. So thank you so much for this. Yes, let's take a short break. We'll take, should we say 5 minutes? You happy
5 minutes sounds great.
So we'll
All right.
Come back at, let's say, 31 past the hour.
Very good. Okay, talk to you again soon.
First of all, I just wanted to say, I can see that, well, you mentioned Yin-type, and it came up in the chat as well.
Mm-hmm.
We did actually have Yin-type as a guest at one of our events. So if people are interested in more, on our website, it is available, but I'm sure you can find more on.
Uh-huh.
So yeah, so let's open it up to everyone now. As I said earlier, if you want to make a contribution or ask a question, you can use the raise your hand function, physically raise your hand, or write your question in the chat and I can read it out for you. To start off, let's go to Bernard.
Thank you. Well, Ruth, first of all, I'm delighted to meet you because although we've had some email exchanges, I've never actually met you physically. So at least
Yes.
it's a pleasure.
Cyber meeting, we shake hands.
Exactly. It's very nice to meet you.
Nice to meet you too.
Digitally, yeah. Well, first of all, I mean, I was actually delighted that your talk because I thought you were going to say things which would be very different from what my view is, but in fact they were very similar. I mean, there was a great congruence. I was always intrigued from the beginning of your talk about the link between res potentia and res cogitans, and I said, well, why doesn't Ruth just marry them up? But in fact, that's what you did at the end, and that's in some sense you were relating them at the end, and that's why I was so excited by your talk. And I have to say that within my own approach, which I'm going to talk about next weekend, in fact, I explicitly associate the hard. I say one requires higher dimensions, both to accommodate mental space, and to accommodate quantum phenomena. And in fact, that's what you were saying. In other words, that it's the same higher dimensional space which is required for the quantum potentials as is required for mental experience. And I loved what you were saying about time and the knitting picture, you know, which again I very much resonated with.
Okay.
And to some extent, I'm going to I'll be talking about some of those issues next weekend, and so I'm delighted it'll be able to tie up with what you were saying. But I have a specific question.
Okay.
And that is the following. It's a question of how one relates your picture, your transactional picture of quantum mechanics, to some of the other pictures. Now, for example, you said right in your first slide that you weren't keen on the model which says that consciousness collapses the wave function. But if one accepts that there is a link between mental space and potential space, quantum mechanical space, and since consciousness is something to do with mind and mental space, why can you not in some sense say that consciousness may after all be collapsing the wave function? So that was my first question. And the second question was, you never explicitly referred to the many worlds picture, which of course is something which Paul Tappenden talked about a few weeks ago. And of course obviously relates to the multiverse theme. So maybe you could be a bit more explicit as to whether you're rejecting many worlds at the outset, or whether in some sense I can imagine the many worlds as having something to do with your potential space. So those are my two basic questions.
Okay. Well, I guess the main thing that I insist on is this idea that we have to have yin. We have to have, it's really the direct action picture of fields. It's a different picture of field behavior. And the reason I don't buy into these standard interpretations that, as they're standardly presented, like consciousness causes a collapse, I don't buy that in the unitary only picture. In other words, if all you've got is yang and all you've got is unitary evolution, then there's no physics behind this collapse. There's no sound quantifiable. There's no way to quantify it. Now, I don't rule out, that within the direct action picture, within the kind of field behavior that occurs in the direct action picture, in which you have either this direct, just force-based thing, or you've got the energy transaction, which actualizes two completely different behaviors. Now, it could very well be that latter behavior involves an element of consciousness. that it involves two quantum systems going, hey, I want to hand you a photon. Okay, yeah, that they're actually having some rudimentary, consciousness-based volitional act. That could very well be the case. But what I'm doing here is, be in a stodgy sort of physics way, saying the physics of standard quantum theory is missing something that without it cannot define measurement within the theory. The problem with the usual von Neumann consciousness collapsing a wave function thing is it's explicitly, okay, well, this is really what they say. Quantum theory describes the system I'm interested in. And then for some reason that I can't talk about, I'm going to treat everything outside the system as not described by quantum theory. And I'm going to say that my brain and my awareness is one of those things that's not described by quantum theory. And it's all of us things that are outside the theory that are going to collapse the part of it that is described by the. So we're talking the Heisenberg cut.
Would it be fair to say your view is that consciousness cannot collapse the wave function in the normal four-dimensional view, but perhaps consciousness can collapse the function if you're thinking in terms of this higher-dimensional view?
Oh, well, I have to distinguish between the higher dimensional ontology and the direct action theory of fields. They're two different things, right? So it's really the field behavior and the fact that this is a different physics, that the direct action theory is quantifiably a different physics, that the physics has a non-unitary process in it. The mathematics is non-unitary. I mean, you look at the S matrix, and the S matrix has a non-unitary character. That does not happen in the standard way of formulating quantum theory. So it's really, this old-fashioned stodgy, yeah, the physics has to be right. I'm insisting that your physics of your field behavior has to have the right physics. And so even if you didn't buy into higher dimensions, well, I think you'd be wrong. I think you'd be anti-realist to not buy into the fact that this is taking place in higher dimensions. But nevertheless, at least you would have, some physics that can describe a non-unitary measurement transition that is part of quantum theory itself. That's what's missing in the standard approach. That is only the standard approach to quantum theory assumes that there is only a unitary behavior on the part of the fields. And if you have only unitary behavior, you're Yang only, you have no real measurement transition.
I see.
You got, you can't get off the ground with having measurement outcomes.
Okay. No, I'm taking too much time, but
okay,
maybe just a yes or no answer to many worlds.
Yeah. The many worlds thing is unitary only. It's a, for me, it's a way of trying to make the unitary only picture work, because they can't explain why you get an outcome. You can't explain why you get measurement. So they just say all measurements happen. Okay. So it also has to has the basis problem in that it has to explain, well, why is the basis of the measurement cat alive versus cat dead? Why isn't it cat alive plus cat dead in one world and cat alive minus cat dead in the other world? It's got this circularity problem where it has to assume a computability, a computation basis that matches our everyday experience. So it has to smuggle that in and get the right, yeah.
Thank you very much.
That's my capsule rejection of many worlds.
That's fine. Thank you.
Sure.
Thank you, Bernard, for coming in and for your questions.
Great questions. Thank you.
The next question we'll get from the chat, which comes from Gary, who asks, can you speculate regarding how the PTI-RTI transactional interpretation may relate to panpsychism?
Yes, I've talked with Jeffrey Mishlove about this. I mean, my own, take off transactional hat and put on a speculative armchair metaphysician is, of course, we have panpsychism. I mean, you can't get, there's the hard problem of consciousness. If you think, like Descartes, that the basic material is dumb, dead, non-conscious matter, then forget it. You're not going to get consciousness out of that. So as far as transactional picture, I mean, as I mentioned it toward the end, and as Bernard observed, it seems natural to connect the quantum realm of possibilities with the mental realm. And since that's fundamental and encompasses everything, it makes sense. Panpsychism makes sense in that way. Now, I should just, because Bernard raised this issue, I should just say why I don't automatically connect res potentia to res cogitans. I don't think they're the same thing, because there's a gradation there, because, you know, I don't want to reify, I don't want to say that because I thought of, you know, in Quine's terms, that possible fat man in the doorway, that there's really an ontological fat man in the doorway out there, you know, that the idea of I can fancifully conjure up any thought I want, that thought might not be described by quantum theory. It might not be, I don't know, you know, so because I don't really know that, I limit the idea of res potentia to those entities that we know can really be usefully described by quantum theory. So it's a more restricted, you could take it as a subset if you want to think of quantum systems as really mental in some way. I don't disagree with that, but it's a subset, it's a more specific subset than just, you know, I can think of a purple unicorn sitting on my computer screen right now, and that probably would not be described by quantum theory, you know, so whatever. So that's a distinction I would just make there. But yes, you know, panpsychism, if only because of the hard problem. You know, you can't have a coherent, in my opinion, you can't really have a coherent ontology of life and mental activity if you want to say, I'm just going to say that it emerges from dead things. So.
Great, thank you, Ruth, and thank you, Gary. We'll next go to Niels.
Okay. Thank you for a very interesting walk through all the hassles with quantum mechanics and etc. I come from a different perspective. I've done 50 years of computation as complex systems, and about 30 years ago, I suddenly discovered there was a situation. We had a fire in King's Cross Station in London, where 31 people died, and London Underground got interested in simulating the station in that respect. And I was worked for a consultancy, and we were asked to help them with that, finding the pathways. And one of the things that interested me was really, I've done transportation modeling for 10 years before on the cutting edge, if you like. So I understood how to get shortest paths and all this stuff. But the question was, even a London Underground station can be so complex that you can't define all the pathways. And then the question is, how does the parallel situation, how do you capture that? How do you simulate? How do you make the people moving realize that there are different options, etc.? And that led to, by turning things on its head, that led to a complete, what we could say, window of possibilities. And it's actually complete. So in effect, once you start studying it further, you realize that is a form of reality, because it finds a irreducible set of shortest paths, or if you could say, indifferent paths.
Yes.
And when I discovered that, then I thought back to my physics days and where I was, I should probably have been a physicist, but I became a structural engineer instead. But in the transportation field, there are actually many physicists involved in that. And I thought about this could be helpful in quantum mechanics. So I was thinking of the double split and that stuff. But I then found that in in our community, I couldn't explain it to them. It's the most simple concept. And it resonates with your idea with the yin. But
Yes.
what is interesting in the transportation model, you only need the yin. That is a complete mind in a sense, because that I then discovered in the transportation model, because you could see that it was a mind that tried to direct everyone, but according to how able they were to move in the space. So in a sense, you could have it from absolute what is called deterministic, full optimized, or you could have it to the other extent by using like statistical things, and you could end up with everyone going in circles. So we use that so by giving it the degree of variance in the system, you could have a worse situation. So that was useful in the sense that trying to reflect that people cannot achieve the optimum.
That's fascinating. So you had a kind of a transportation network. You had nodes, and you had to try to optimize.
Yes.
Yeah. So that's like a complex system, really.
It's so complex now that I think to do even something fairly complex,
yes,
a supercomputer will take 3.5 billion years to. What we do in seconds, but I can't. People, they go to sleep once you start talking about it.
Well, yes, so, it's very complex. Yes, complexity.
But it resonates exactly with yours. And you asked if it's a mind. It is a mind in the sense that if you understand artificial intelligence, they have what they call back propagation. That is going from the goal back towards the past. So from the future to the past. And they are discussing why back propagation is necessary. They don't actually see that is actually the mind in the
I see. Yes.
I will stop now, but I thought it was the first time I really have, apart from Bohm, where someone had approached it from the yin side as well.
Well, yes, I mean, I that is such a huge topic. I mean, we could have a conversation about that. It's the idea that considering the different options, the different possibilities, that you may optimize what you're doing by doing this, backward hypothetical. What if I, that's like the role of the absorber. That's the advanced propagation that was Bohm's insight early on. That you can. It's not just yang. That's how humans. That's how we actually think.
And this is our proper mind. And you mentioned
an aspect of mental.
And you mentioned Toller. So in order, because things progress in a wide aspect.
Right.
And Toller talks about the now. And I think there's been other speakers talking about the now in the sense that your model has to be able to do things synchronously.
Yes.
Yeah. And that's exactly what it is. So I would love to work with people on that. I'm not so good at writing papers. I don't like. And every time I have written a paper about this, it gets dismissed because it hasn't got many references, because it's very simple.
That's a barrier. Yeah, I know what you mean.
Thank you.
Yes, we'll chat.
Thank you. I will stop now.
Send me an email and we can talk about that.
Yes, I would like to. Yeah.
Yes.
Thank you, Neil. We'll go next to Sharon.
Thank you. My question is going to be very basic because I'm not a physicist. The last time I looked at physics as a subject other than through PARE was in high school. So it goes back to what you had said about there being no space-time container, right? The question of container. Right? So I get all of the, all of the relationship stuff makes sense to me. Yin yang makes sense to me. It feels right experientially. Potential feels right to me. All of that I can say yes, I can, I can get. But at some point, even when I think about infinity, right, I come up against something that says, what is infinity in, right? Where is the container? And if there's a container for that, what's the container for that, right? So even when you have the square inside the square, the 3D inside the 4D, my mind wants to say, what's the 4D in? And doesn't everything have to be in a thing? But, what is, from a physics perspective, a no thing? How can that exist? A no-ness. I'm into God at this point, but it's like, how can that actually be possible? And I'm hoping that since you do such a good job of concrete examples, that you can get this in my head.
Well, this is a deep metaphysical question, and I think a lot of kids think about before school drums it out of them. I remember asking that question in when I was in third grade, and we were having fun chatting about that, and then the teacher came in, now get back to work. But I did that when you were talking, the audio was kind of falling in and out, so I may have missed some. But as I understand it, you're kind of you're challenged by the idea of infinity, and can't there be a container or of something? Now, did you make a reference to God in your comments?
I did. I'm my mind just freezes up at a point where there is no container, and
that it's sort of like you feel like in order to conceptualize it, you need a container. And I think this is a beautiful example of the left brain going, because it's the left brain, I think, that wants to, must create geometric, and it's like, I feel your pain because I have that same, but I think if our right brain could get more involved, we might be able to, and I'm not saying I don't have an answer for you, but I'm kind of thinking it's a right brain understanding. In other words, that it's, that maybe what all that exists is a singularity, and what's illusory is the idea of volume, that volume is like a projection, and that I think that the basic answer is where are we in? If we are in a container, it's the quantum substratum. It's the transcendent underlying quantum substratum, which is not a container. It has no structure. It has no metric in the usual way. So it's it's fluid. It's alive. It's like the trees, and so think of a tree or a parsley seedling growing. It's an action. It's an entity in an action rather than what am I in? So I don't know. Again, it's kind of a left brain cone that the left brain is asking us this question.
So, and I did actually mention God. So I do maybe a certain concept of no. It's everything and nothing, no thing, and
there's
and singularity sort of speaks to that a little bit.
There's a Hindu term for that that I'm blanking out on right now. Shunya. An ancient Vedic term. Shunya is this transcendent fullness and yet emptiness. So it's great. The ancient, the ancient Vedics were all over there. They got this stuff, So I think that those kinds of, if we go to the Eastern thought, they're more right brain oriented. And that's why I think they had a little more insight into how to understand these deep metaphysical, issues. Yeah.
It's a conundrum.
It's not really an answer, but I salute your question.
Well, thank you, Sharon, for coming in. So we've got two questions from the chat that we would like to ask you. The first one is more of a bit more of a like clarification.
Okay.
Someone asked, basically noticed that your views on the transactional interpretation seem to be a bit more broader than the more conventional views. Is that accurate, or?
Well, broader in the sense of maybe that I'm entertaining this ontology. I think so. I mean, I know, like as I said, John Kramer, made very clear that he is not a fan of the possibilist picture of the transactional interpretation. But yeah, I mean, I think you need it for coherence. I think that whenever people are trying to be sort of more conservative, if you will, they're just being anti-realist. I mean, they're just saying they're being anti-realist about the theory, because the theory itself demands a complex higher Hilbert space, a complex higher dimensional space. Those are the theoretical descriptors of the quantum systems, and also in TI. So even with basic quantum theory, the people who want to be more, empirically minded and more conservative, they're not really accomplishing anything, because they're just dodging, they're dodging an issue. So I'm just kind of embracing it. I'm saying, yeah, quantum theory is multidimensional. A system that can, a system of n particles has a 3n dimensional complex Hilbert space. If it doesn't live in space time, it lives in this space that describes it, not a space that doesn't describe it. So, to get coherence, theoretical and interpretive coherence, you have to take the bull by the horns and just admit that that's what's being described. And if you don't want to do that, then you retreat into instrumentalism and say, quantum theory is just an instruction booklet for predicting things.
Okay, great, thank you.
Yeah.
Thank you for that clarification. And then the second question is in regards to the concept of time that you've proposed. So the question reads, can the active imagination be one of the methods by which we can dissolve the corpus callosum and face the future? Or is there a way to dissolve this?
In terms of sort of facing the future, I think it does make sense in terms of imagination, in terms of, because in the imaginal realm is, I think, entertaining the possibilities. It's very right brain. It's very much, in the knitting analogy, it's very much looking at the balls of yarn that I have at my disposal and looking at the patterns and feeling free to decide that I'm going to change the way I'm actualizing things. So, as long as we're clear that the future doesn't mean a hunk of space time with events actualized in it, then it does certainly make sense to say, I'm going to, in my mind, I'm going to entertain the possibilities. So, yeah, I mean, I think that's certainly a way to deal with that issue of, well, what is the future? It's possibilities, so yeah.
Okay, great. And by the way, that was from Sophia. Okay, well, I think, we've reached the end of the hour, so I guess we should start closing this session. If there are other questions, please do raise them on Sutra, and maybe you can discuss them there.
Sure.
Yeah,
happy to.
You're on Sutra. You already said so. So
yes.
So Ruth, do you have any final comments you would like to give us just before we close?
Oh, gee, I feel like I pontificated so much already. I guess I don't really have anything to add. Just the idea that, again, I do think that, that Bohm was kind of envisioning this kind of process. He probably didn't even know about the direct action theory back then, because, again, I mean, Kramer didn't come out with his proposal until the mid-'80s. And my sense is that if Bohm had known about it, that he probably would have appreciated it, because it seems as though he was actually describing that kind of picture. So, I kind of toss that out for people to consider.
Okay, well, thank you so much, Ruth, for today's session. Your presentation was amazing, really content dense, really give us something to think about. So thank you so much for that. Thank you for everyone who have come. Thank you for everyone who contributed, whether through their questions or through the chat. Yes, hope to see you all tomorrow for the session with Tim Modlin on science, philosophy, evidence, explanation, and fine-tuning. If you have any questions, please do write us on our website or on Sutra, social media, or just email us directly. To contact me, you can contact James at paracenter.com, or to contact Eleanor at paracenter.com. Thank you all again for joining us, and we'll see you again soon here at the Paracenter. Bye-bye.
Thank you. Thanks again. Thank you for inviting me.
Thank you. Thank you for coming.
Many thanks.